next part on the specification is we are starting to think about deposition. That is when material is dropped by the sea and it creates features and landforms such as beaches, sand dunes, spits and bars. Today we're mainly going to think about beaches and how that material is moved along those beaches. Today we're going to be thinking about how the sea transports material. First of all, have a look at the three pictures which are on the slide, and I would like you to try and think about what are the three processes that are taking place along the coastline. Pause this for a second and see if you can come up with the names of the three things that are taking place in each of the pictures. Okay, did you get picture 1, erosion, picture 2, transportation, picture 3, deposition? So you may have stood at a beach and not really thought about what the waves are doing, but they have all sorts of actions taking place within them. We looked the other day about how wind is creating waves and how the stronger the wind, the bigger those waves are going to be. But when you stand on a beach and maybe try and stop your feet from getting wet, the waves that move up and down that beach are undertaking two actions. As that water rushes up the beach towards you, that is known as the swash, and it pushes sand up the beach. When the water then stops coming towards you and it then rolls back down the beach because gravity is taken over, that is called the backwash. Now, if the swash is stronger, it can push material up the beach and it can help beaches get bigger. If the backwash, though, is stronger and bigger, it can take material off the beach and it can actually erode away at the beach. So understanding these two motions of swash and backwash are really important for us to understand what is happening at a beach. You now need to watch the first clip on the right hand side of the page in Frog. As you watch this clip, think about the features that waves have as they break on the beach. So to think about that swash and backwash, we have to think about what is happening to waves out in the sea. When water is quite deep, the energy in that wave, the energy that's been created by wind passing over the top of it, is able to create those waves moving up and down. And that energy moves around in a circle, as can be seen on the left-hand side of this diagram. That circular motion is unaffected by the base of the sea. And so the wave will just go up and down, up and down. As the water gets closer to the shore, the seabed starts to get shallower. You can see the base down here. Now, as that seabed gets shallower, the energy in the water has got less space to rotate. So it starts to become a bit more of an oval shape. The bottom of that energy starts to rub on the seabed. The top has less friction. The top is able to move forward faster. So a wave will start to break. The top of that wave will start to crash over the bottom of it. As you get even closer in towards the shore, the top of that wave will crash over even more because there is less friction affecting on it. That wave then crashes down onto our beach, pushing material up the beach, a swash. Every beach is slightly different. Some beaches are really gently sloping and the wave might break a long way out to sea. And some beaches can be very steeply sloping. And if you've been to different beaches, you'll know that sometimes you can just stand on the side of the water and the wave will crash onto you at the very last minute. So beach that's very steeply sloping, the wave would probably crash down onto you at the very last minute because of this process we looked at above. Whereas a beach that's very gently sloping, the wave might start to break much further out. So if you want to go to the beach and go surfing, the beach on the left, this one here, would be much better for surfing because the waves would break further out to sea. Whereas this beach here, the steeply sloping beach, would actually not be so good for surfing because the waves would break at the very last minute when the water becomes shallow. The two main things we need to understand are there are two types of waves. Waves that are destructive, which crash down onto beaches and erode away at those beaches, and waves that are constructive and tend to be much smaller and push material up the beach. With the destructive wave, the backwash is bigger than the swash. Of the constructive wave, the swash is bigger than the backwash. Bigger swash means the material is pushed up the beach. Bigger backwash means the material is taken off the beach. So you've now got a little table that I'd like you to either draw or to use one on the sheet that you can find the download on the right hand side. And onto that table, I'd like you to put in the statements from the bottom of the page here. Try and decide what are the conditions that you would find for a constructive wave, and what are the conditions and features you'd find for a destructive wave. Pause this here while you have a go at this task. Okay, let's go through these answers. So destructive wave tend to be forming in very big windy conditions. They make very high waves. The backwash is stronger than the swash, and there tends to be quite a lot of them. And all of those are moving material from the beach. Constructive waves, depositing material on the beach. They're formed in much calmer conditions with lighter winds. The waves are not as big and not as high. The swash is stronger than the backwash, so it's pushing material onto that beach. And they don't tend to be as frequent, maybe 6 or 9 every minute. So in constructive waves, we've got waves that are building up beaches. So the deep positional landform we saw at the start of this lesson of the beach has been created because constructive waves are pushing sand onto that beach. We also need to then understand about how material might move along that beach, and that's all down to swash and backwash. So swash is the water going up the beach, backwash down the beach. Now backwash always runs down the beach in a straight line. It's affected by gravity. So gravity will pull the water down the beach back towards the sea. Swash, however, is affected by the angle at which the waves hit the beach. So swash could go straight up the beach, or it could come in diagonally from the side. And it's that feature that results in material moving along our beach for transportation. So if the beach has wind that blows waves at an angle, swash will go up the beach at an angle, water will then come down the beach in a straight line, next wave will push material at an angle, down in a straight line, and so on. Now when those waves do that, they move sand and stones up and down the beach. And that process of swash and backwash is moving things from left to right in this example. And that movement of water with sediment, with sand and stones in it, is called longshore drift. And it's that process that we need to be able to understand and we need to be able to explain. So the process of longshore drift that we are thinking about involves the waves being pushed up a beach at an angle. So on the diagram I'm just going to draw, got our beach. We've then got approaching the beach, the wind. That wind is blowing in at an angle. As a result of that, the waves will then be blown towards the beach at an angle. When those waves hit the beach, swash, the water that gets pushed up the beach, will go up that beach diagonally at an angle. Backwash, though, will then run down the beach under gravity in a straight line. The next wave will come in and push the water, the swash, up the beach at an angle. Backwash will run down in a straight line. The process will repeat itself. Any bits of sediment, sand and stones will get pushed up and down that beach following the pattern of the waves. So the process of longshore drift is happening because waves are approaching at an angle. So we'll make sure we label that process onto our diagram. To stop longshore drift, what you may have seen on beaches around the world is we build big wooden fences. And those big wooden fences are known as groins. And those groins stop that process of longshore drift. And the waves can no longer move the sand any further because they've hit that groin. And so what then happens is the beach actually builds up on this side of the groin and stops the sand moving along that beach, which is really important because the beach is that boundary between the sea and the land behind it, and waves lose their energy as they travel up the beach. So it's really important to have a nice wide beach because the waves then can't hit the land at the back of the beach and potentially erode it. If the wind was to change direction and come in head on towards that beach, our waves would approach the beach straight on, and therefore the swash would go up the beach in a straight line, and the backwash would come down the beach in a straight line. And because of that, material would just get moved up and down the beach and wouldn't really be going anywhere. So the direction of the wind is really important. Most of the time in the UK, our wind is blowing in from the southwest. So particularly coasts on the south coast of Britain are going to get waves that approach them from the southwest. Obviously, if the wind changes direction, the process of longshore drift is going to stop. So in some places, you may have for large periods of the year longshore drift taking place, and at other times in the year, longshore drift might stop or pause because the wind direction has changed. So longshore drift is really important for us to understand how material is moved and how material can potentially stay on a beach. So here's a diagram which shows us that process and what is happening. So we're now going to have a go at the following GCSE question. Using a diagram or diagrams, explain how the sea can transport material along the coast. In order to do that, we are going to look at the YouTube clip that's on the right hand side of the page. After you've watched it, we're going to then answer or have a go at answering the question above. So first of all, pause this while you watch the clip on the right hand side. So now that you've watched the clip, we're going to have a go at answering this GCSE question, and we're going to try and include the words at the bottom. So we've got words such as swash, deposition, weak backwash, prevailing wind, all key words that we've mentioned in this lesson are really important to include in our answer. Our question also says we want to include a diagram or diagrams. So that's really important because that diagram is going to help us explain how the sea transports material on the coast. In order to explain it, we are going to need to use labels and annotations. We can't just simply draw a diagram because that diagram would not be explaining. So those labels would need to make sure we're doing that, either through annotations on our diagram or maybe a key that would then refer to what we say in our answer. So we may end up with a diagram something like this one, your version of something like that, and some explanation along that diagram. So you now need to pause this clip while you have a go at answering the question and drawing your diagram. This should probably take you just about 10 minutes. You now need to watch the YouTube clip in the links on the right hand side of the frog page from 9 minutes 47 to 15 minutes 30. Pause this while you do, and then when you've watched it, unpause this clip and move on to watch and read the final questions of this lesson. Now that you've watched the clip, you need to answer the following 3 questions about the effect that building groins in Bournemouth has had. Question 1, why is the Bournemouth beach important? Question 2, what has happened to Barton-on-Sea and why? Question 3, what else has led to Barton's problems? Pause this clip while you have a go at the questions and finish today's lesson.